Our next presenter needs no introduction, but of course, I will introduce her nonetheless. Regina Obey is a member of the PostGIS Project Steering Committee. She's the author of PostGIS in Action and Postgres Up and Running, and probably other books as well. She's one of the earliest users of PostGIS and is now a core contributor and the developer who keeps us all on track and keeps the trains running on time. Bringer of order from the chaos, Regina Obey. Welcome to PostGIS Day.
Hi, y'all. I'm also the maintainer of the Windows PostGIS bundle, so if you want to complain about that, I'm the person to yell at.
To think.
And I'm working on the fourth edition of Postgres up and running, and also the second edition of PG routing. So hopefully get done this year or early next. So today I'm going to take you on a travel back in time to the year 1974, when
Good
I was
year.
a baby of 3. And this is before Postgres even existed. Prior to Postgres, there was a database called Ingress, a research project started in 1974, around the time of System R, which is when relational databases started. And it was funded to create a prototype for a geographical and graphical database system. But as all good funding initiatives go, why spend money on what you were supposed to be building when you could build something else that more people can use? And so much of their time was spent building a relational database system instead. And to say that it didn't have any geographic use would not be quite right. They did have data types such as polygons, points, and line segs to satisfy at least some of the grant requirement. And Ingress turned out to be a pretty impressive relational databases because it was open source. A lot of the proprietary systems spun off from that. It also had a language called Quell that was closer in syntax to the relational algebra that the father Edgar F. Codd of relational databases wanted. So it catered more to mathematicians than it did to normal people. And it also led to other initiatives such as introduction of parallel queries, distributed data, distributed execution. But as far as graphic and geographic, it fell a little short of that objective. And today, Ingress still exists, except it's closed source. And you can find it was the seed for other closed source databases. So things like Sybase, Microsoft SQL Server, Nonstop SQL, all those still exist today, and those had their foundation in Ingress. So after the Ingress project was done, another database project started by the same people that founded Ingress. And this database was called Postgres. It didn't use any of the code that Ingress had. It was a reimagining of what Ingress could be if instead of hardwired types, the type system was more flexible and it provided flexibility for indexes and operators and all that good stuff. And for testing all that, we have our favorite friends, Polygon, Point, and LineSeg, which showed up in the code base. And it had a language that was like Quell, called PostgreSQL, which could do something else that was interesting. And that interesting thing was time travel. And the foundation of time travel was how it stored data, that it would never delete data, it would just append data. So what's in a name? So we call Postgres by Postgres or PostgreSQL. And Postgres in the beginning didn't even support SQL. That came much later, around 1995. During that time when Postgres was getting its SQL footing, it crashed a lot. And so the years after the research project ended and Postgres found its way into the open source world, the objective was to prevent it from not crashing so much and to try to catch up by beefing up the SQL support in it and extending that. And so today, the biggest problem that Postgres has is a marketing one because PostgreSQL is hard to pronounce. And so when salespeople try to sell it, they stumble on their words, which is really bad if you're trying to sell stuff. And so you call it Postgres, but then it doesn't really match with the website. So is it the same database? We don't know. And then if you're in the spatial world, you might call it PostGIS. And the spatial people haven't heard of Postgres, so it's just called PostGIS, or it's PostGIS, or it's PostGIS. So it goes by several different names. So forget about marketing because marketing is not important. Let's talk about the let's not crash so much years and how that led to where we are today. So the let's not crash so much years are the years where the code was smoothed out a little bit, some complexity was removed. And the biggest pieces of complexity were the extended type support system and this time travel thing. And so there were discussions to remove both because who really needs extended types? Who really needs to time travel? But shortly after that, while this debate was going on, another project started called PostGIS. And this built on the extensibility that Postgres offered. But what was special about PostGIS is that it actually made good on the promise of a geographical database management system. And so that G that's been lingering around since Ingress was finally deserving of a capital G instead of a small g. So since PostGIS, the extensibility in Postgres has only increased. We now have a new SQL grammar called create extension, which allows you to dynamically load extensions into your database. And how deep you can go to change Postgres has been continually changing. Even if you just consider the spatial extensions we have, that's a rich set. But if you go beyond that, we're talking about hundreds of extensions that you can install in Postgres. So this time travel thing that I talked about that was ripped out, this was ripped out before Postgres even came on the scene in 7.0. The last version of Postgres to support time travel was 6.5. And what exactly was this time travel? Well, it allowed you to do what's called flashback reporting, where you could say for any point in time, what did my database look like? If I were to generate a query that matches exactly that paper report I gave my CEO, would I be able to do it and how would I do it? So you would just simply state the date that you gave the report and you could generate the same query exactly as it was. And it's used for other things, like it's a good way for recovering data. If a user deletes data or updates data, it's a way to check if your database has been tampered with. And today, lots of databases support time travel. So Snowflake supports time travel. Oracle supports time travel. SQL Server supports time travel. And they all support it much in the same way as what the ISO SQL standard says that it should be supported. So unlike the Postgres way, um, you have the choice of what tables can support time travel, whereas in the Postgres days, you were stuck with time travel. All your tables support time travel. You had no choice about it. And so even though time travel was removed from Postgres, there's still remnants of it. For one, you just need to look at the mascot we've got, an elephant. An elephant's known for never forgetting, just as Postgres is known for that. And if you look deeper in the core of Postgres, you'll find that every single table in Postgres has hidden fields. When you do select star sum table, you wouldn't see these fields, but if you explicitly select them, you will see them, and they'll tell you an idea of when a record was created and if it's the latest version. And then there's a problem that haunts Postgres, that has haunted it for quite some time, but it's gotten much better these days. And that's the idea of vacuuming, which is to remove dead tuples. And the reason why this even existed is to archive dead tuples to tape so that you could still query them. You could still do time travel. So where does that leave us today? So even though the core of Postgres no longer supports time travel, you'll find time travel living under the current of many extensions. If you were just to look at our own backyard, you'll find that even Postgres, the core has improved on support of temporal, and a lot of this is used by users to build their own time travel systems. And then there's PostGIS. Does PostGIS support time travel? Well, many people believe that the ST in the SQL Multimedia Part 3 standard for spatial stands for spatial temporal. It's still unclear whether that is what it stands for because the specs never tell you what it stands for. They just state that all functions and types will start with ST. And then there's this mysterious M coordinate that PostGIS and many spatial databases have, which many people use for either measuring things or for recording time for trajectories. And you'll find several functions in PostGIS that support trajectory. And then there's an extension, which is relatively new, which builds on top of PostGIS, except it introduces temporal types, which are more explicit than the use of M. And those are used for mostly managing spatial trajectories, but they can be used for non-spatial trajectories as well. And there's a recent book that came out about a year ago that has several examples for using it, written by the author of the MobilityDB extension. So now I'm going to show you some examples of time travel. So first of all, in our work, we do deal with a lot of time series like data where we need to do analysis such as determining length of stay in hospitals, if a person is covered for a particular period by their insurance, if people have worked enough to garner pension and how much pension they would get. And so in the past, Postgres only had range types. So range types aren't sufficient if you need to record gaps in time. So my partner, Leo, what he would do is he would leverage the PostGIS functions to manage time. And so he basically modeled time as a line. For the most part, all he really needed was the X coordinate, but on occasion, he would also need the Y coordinate to record certain things. So if we were to say record salary, convert a salary period to a geometry, he'd have a function something like this. And the way he recorded time, because all he needed were dates. He didn't need to record at the second level. He would use Julian calendar days. And so he'd convert a date to a Julian calendar date. So here's an example of what that would look like if you're using it for managing salary data. You'd create an employee table and you'd have a salary history column that's a geometry. And then you can have a function that converts a date to a vertical line. And then if you want to make your life easier, you can create a cast that converts a date to a geometry. And so then if you wanted a table, a view that kept track of what the latest salary is of anybody, you would create a view on top of your table that looked like this. It would basically translate the geometry back to a salary. And it would convert the X coordinate back to a date. And then, so you don't really have to think in terms of geometry. You could create a trigger, and instead of trigger, against the view. So here, so views can't have real triggers, but they can have instead of triggers, which is instead of actually editing, updating the data in the table, do this instead. And so if I were to add data, so the trigger that I created here, I'm actually converting inserts to updates if the record already exists, so that I always have at most only one record per employee in my employee table, even though it looks like I'm inserting tons of data. So if you look here, supposedly I'm inserting 2 records. And here, supposedly I'm inserting 6 records. And in this one, I'm inserting 4 records, but I'm not really inserting. If you look at my original table, you will see there's only 3 records. So all that inserting converted to just expanding my line string. And if you were to look at the view, it would show a pay period date and a salary, which is the latest. So this has a nice feature that you can determine what anybody's salary at any point in time using the built-in functions in PostGIS. So I can ask the question, for this date, what was my salary? Simply by asking what point in time intersects, what salary intersects with this point in time that I'm giving you. And so it would show only Sam, because only Sam was working in this period. So he's the only one that's going to show up since I'm filtering for only those that intersect. And I could do that for another date, similar thing. So I would see anybody that was working at that time. I can check the duration that anybody has worked. So that tells me the number of days people have worked. And you could do a similar thing with mobility DB. It's a little bit less cryptic with mobility DB because mobility DB understands time as time instead of as a number. So if I were to recreate the view the table, I would use this data type that's provided by MobilityDB, which is a time float, a sequential time float. And instead of using the PostGIS functions, I would use these functions provided by MobilityDB. And a time float would look something like this in its canonical form. So you could make out the dates. It's not as cryptic as a whole bunch of binary bits. And again, I would do a trigger so that I would end up appending to my sequence. And I could insert the same records using exactly the same syntax as I did before. And one thing that's nice about MobilityDB is if you specify a type as being sequential, it won't allow you to break that rule. So if it's sequential and non-overlapping, this will fail because it overlaps with data I already have. And so you get the same answer, except the sale history is a little bit more legible. You can actually make out stuff. And you can answer the same questions using this value at timestamp. And one thing I noticed is a little different is if you ask for the duration, it gives you 84 days and 1 hour, because I realize now that the date I had specified here was during a period where there was time where there was daylight saving. So I actually gained an hour. So I worked an extra hour during that period. And MobilityDB is primarily known for managing spatial data, so data in motion like transportation or bird flight or things of that sort. So you generally have like a GPX file that you would load in. And so the way you could load in a GPX is convert, so each point you can convert to a temporal geographic point. And then you can aggregate them using this append instant. And so you have, of course, a binary thing. And like PostGIS data, you can create a gist index on it. And the neat thing about it is, well, first of all, your operations are a bit more intuitive. You don't have to do this convert back and forth between geometry to do temporal checks. And it's also got other neat functions like being able to compute speed. I think I had another one. There's an average speed thing. Or, figure out the average speed of a trajectory. And there are a whole bunch of other functions that you could do with it. So the other thing that's useful is, let's see, if I go back to this, you see that it allows you to convert a temporal MobilityDB back to geography. And the way it does it, it converts it using M for time. So you can go back and forth between the two. Okay, I think that's about it. Does anyone have questions?
You left everybody stunned. Seems
Really? Did I?
like. Then there used to be a contrib extension, table history.
Oh yeah, there is. It's still there, and I haven't looked at it
Is or
yet lately.
was? I was just looking for it and I couldn't find it.
Yeah, it's in extras, but it hasn't really, we never turned it into an extension.
Yeah. Oh, it's our extras.
Yeah, our extras.
Okay.
But there's also another extension called Period, which tries to simulate the actually, let's see, do I have it here? This one. I think I kind of glossed over it. Uh Yeah, so there's this extension called Periods, which tries to simulate the ISO SQL standard. But the problem here, which I think would be neat, a feature that would be nice to have in Postgres is I don't think there's a way in for an extension to add grammar to SQL.
No, not at this point.
Yeah, so they're kind of forced, they do the best they can to simulate the ISO standard, but they can't get the syntax because an extension can't introduce new SQL syntax.
Mhm.
But that would be neat because imagine all the things we could do, Paul.
I've always liked, well, I liked history in time travel, but I find whenever I actually start reading the standards for temporal data, my eyes glaze over because of the whole system time versus world time disjunction,
Yeah,
the idea that every record has to have not one time, but two time, or sorry, not one period, but two periods.
yeah,
I
it's
find
always
that to be a bit
annoying.
much.
Yeah, so I think people end up reinventing their own way of handling it because at least you understand what's going on.
And the temporal people will tell you that you've done it wrong.
Yeah,
Inevitably, your invention is too weak and does not cover the various corner cases they can lay out.
yeah. Yeah, I think I always end up inventing my own because I tried to use the SQL Server one once, and it was because I couldn't figure out how to rewrite history, or even if you could rewrite history, because you know if a load goes bad,
Yeah.
or you record data out of sync or something like that,
So we do
you
have
can't.
questions on the channel.
Oh, okay.
Phil asks, how does this differ from MVCC? Don't most databases do that now, including Postgres? Hmm.
How does it? It probably doesn't too much. Well, I think the way others implement MVCC, they have a separate file. It's not appended to to the same table.
Yeah, but Postgres's handling of MVCC is in fact like an outgrowth of its old time travel facility.
Yeah.
Yeah. Shoaib has a mobility DB question. I've been dying to find good data sets for GTFS. GTFS RT, is there now a good source in your experience to try more use cases around road networks and traffic?
Yeah, I was going to use, I think like MassGIS has GTFS, and I was trying to understand it. I still don't have my head around GTFS. I did have an example in here for GTFS, but I took it out because I figured I wouldn't have time to cover it.
And the final
But
question is,
mhm.
have you seen some of the space-time data stuff that Josh Campbell is working on? I think somewhat related, asks Elizabeth.
No, I don't even know who
And
Josh Kimball is.
yeah, he's affiliated with the State Department, and his problem is the fact that international borders change all the time, and you will definitely want to keep a historical space-time view of those changes.